Welcome to this video on SDLC, the structured lifecycle designed for AI-driven development. We will explore how to transition from informal coding practices to a more rigorous agentic engineering approach. The software development lifecycle is evolving. We are shifting away from vibe coding, relying on casual intuition, toward a disciplined model of agentic engineering. This video introduces the SDLC framework. It features a neutral core, specialized domain agents, and gated stages to ensure governance and traceability from ideation through to final operation. With over 80% of developers using AI tools, the task of code generation is largely solved. The real challenge now is the craftsmanship of specifying intent correctly. Ad hoc workflows fail when context drifts. The SDLC solution provides structure, approval gates, and persistent memory to prevent recurring mistakes and maintain control. The difference between success and failure lies in verification. Vibe coding relies on manual checks, while agentic engineering uses automated evaluations and CI/CD gates to minimize risk. Economically, vibe coding often leads to a, quote, maintenance tax due to high token usage and friction. Agentic engineering requires higher upfront investment but delivers sustainable, low-cost scaling. Our interface with technology is shifting. As we move from simple autocomplete to autonomous agents, the developer's focus transitions from writing syntax to defining intent. AI compresses implementation time, but requires more emphasis on design and evaluation. The role of the developer is transforming into one of reviewing, guiding, and verifying AI outputs. In the AI-driven SDLC, the process moves through 4 key phases: planning and architecture, implementation within a sandbox, testing and feedback loops, and final deployment with automated monitoring. Think of this as a factory model. The developer designs the system, and agents handle the translation and execution. Automated tests then serve as quality gates for verified software shipping. Beware the 80% problem. AI can generate the bulk of a feature quickly, but the final 20%, including edge cases and trade-offs, requires dedicated human attention. While agents automate boilerplate, the final 20% demands deep architectural context. Errors here are often conceptual, potentially causing long-term maintenance issues if not reviewed by a human. Context engineering is the vital skill of this new era. It involves carefully managing instructions, knowledge, memory, tools, and guardrails to guide AI agents effectively. Ultimately, agentic engineering replaces casual prompting with rigorous systemic verification, ensuring that your development process remains reliable and low risk as you scale. Let's look closely at the differentiation. It is not just about using AI, but how we systematically verify the outputs produced. We see a spectrum from vibe coding to full agentic engineering. Vibe coding focuses on speed with casual prompts and disposable code. However, professional development requires the rigor of structured, agent-assisted workflows and formal automated evaluations. To move forward, remember this: tests verify the deterministic system, while evaluations verify the non-deterministic trajectory. You need both to move beyond simple vibe coding. In this model, the developer's output is no longer just the code itself. Instead, you are building the factory, the system of agents and guardrails that produces the code. This factory floor includes a developer zone for setting specs and design guardrails, which feed into a sandbox where planning and coding agents operate and iterate based on test results. Developers now have a dual role. You act as the conductor for real-time synchronous in-IDE tasks, and as the orchestrator for asynchronous goal-level delegation across multiple agents. The goal is write once, run anywhere. By centering your methodology in a harness-neutral core, you maintain consistency across various interfaces like Claude Code or different CLIs. This ensures that your state machine, audit logs, and referee systems are byte-identical across every interface, effectively eliminating fragmentation in your development environment. Finally, consider the token economy. You can optimize costs by balancing static context environments, which are always loaded, with dynamic environments that pull in specific agent skills on demand. By using dynamic context for RAG documents and tool results, you allow the model to remain a lightweight generalist that only adopts specialist roles when triggered by task matching.